On homework 2.3, there are a few sections I'm going to help you with. The first is to say if the functions are inverses. And there are two ways to do it. One is you can start with any function, either of the functions, find the inverse, and see if it's equal to the other one. For instance, here we could find the inverse. The way we do that is by switching x and y. So y will become x, and x will become y. Notice that nothing else changed. The y became x, the x became y, but everything else stayed in the same place. And then we're going to solve for y and see if it gives us the other. Since this whole side is being divided by 2, we need to multiply by 2. And we get 2x equals 4 plus 3y. We need to get y by itself, so we're going to subtract 4 on both sides. 2x minus 4 equals 3y. The last thing we're going to do is we're going to divide by 3. We could distribute and get 2/3 x minus 4/3, but let's just stop right now and see that this is the form that the other one is in. So we can see that this is y equals 2x minus 4 over 3. That is the other one. Now we need to say, are the two functions inverses? Yes, the two functions are inverses of each other. Now there's another way we could have done that, and I want to show you. One way you can do it is you can see, is f of g of x, which means if you plug the possible inverse function into the original function, does it give you back the original input, which would be x? So remember that inverse functions will take the outputs of a function and give you back the input. So if you plug the entire function in, you can see, does it give you back the original? And let's see what happens if we do that. So f of g of x means we take all of g of x and we plug that in for x. F of anything means you plug whatever that thing is in for x. So we're actually plugging all of g of x in for x. We are substituting 2x minus 4 over 3 in for x. And so what that looks like is f of x, or f of g of x, is going to equal 4 plus 3 times, instead of x, we're plugging in 2x minus 4 over 3, all divided by 2. And so we're going to simplify this and see if it gives us x. Well, you'll notice here 3 is multiplying times 2x minus 4, and 2x minus 4 is also dividing by 3. So multiplying by 3 and dividing by 3 cancel out. We get 4 plus 2x minus 4 over 2. We can combine like terms. 4 minus 4 is 0. 2x divided by 2 is x. And so that means that no matter what we put in for x, g of x will give us something, and f of x will undo it and give us back x. And so the two functions are inverses of each other. If you get that f of g of x equals x, yes, they are inverses. All right. The next section says to find the inverse of each function. So we know how to do this. We just switch x and y. X equals 2y squared, and we need to solve for y. So we're going to divide by 2 because y squared is getting multiplied by 2. X over 2, or 1/2 x is probably a better way to write this, is equal to y squared. I'm going to scratch this out to make it less confusing. And the last thing we're going to do is we're going to take the square root on both sides. So we get y equals the square root of 1/2 x. Sorry about my messy handwriting, that's kind of ugly, because the square root and the squared canceled out, and so we just ended up with y. Now, the problem is, we know this is a parabola. Looks like this. It's not shifted left or right, it's just right there, and since it's a parabola, it's not a one-to-one function. To make the inverse a function, we need to restrict the domain on the original. So what we're going to do is we're going to say, this is where it will be no x values, no y values getting repeated if we cut it off right at the vertex. And so to do that, we just say x is greater than or equal to 0. That's our domain restriction to make this parabola a one-to-one function so that we can actually have an inverse that is a function. One more I'm going to help you with is this next one. Is a little bit weird. You may have done ones like this in Algebra 1 or solving this type of problem in Algebra 1. You may not have. We're finding the inverse, and that's easy. We're going to switch x and y. X, oh man, ooh, wait, hold on. Let's go back to this last one for just a second. Because it started with g of x equals, we shouldn't leave it as y equals at the end. we should write g inverse of x equals square root of 1/2 x. That was sloppy of me, and I apologize. I almost gave you guys bad advice. All right, on to this next one. F of x becomes x, negative y plus 1 plus 2. Now we need to solve for y. The first thing we should do is get rid of this 2, move it to the other side. And so we get x minus 2 equals 1 over negative y plus 1. All right, now this is a little bit weird. We're trying to get y by itself, but it's in the denominator. And so since 1 is being divided by negative y plus 1, we are going to multiply by negative y plus 1 to undo the dividing by it. We're going to have to multiply by the same thing on the other side. So we're going to multiply by negative y plus 1 on both sides. And we're not actually going to multiply this out, because what we're going to do is to get oh man, sloppy math, I apologize. To get y by itself here, we're just going to divide by what it's multiplying by. So negative y plus 1 is being multiplied by x minus 2, so we're going to divide by x minus 2. And the multiplying by x minus 2 will cancel out with the dividing by x minus 2, and we'll get negative y plus 1 equals 1 over x minus 2. We can subtract 1, so we get 1 over x minus 2 minus 1. And the last step is to get rid of a negative y, we need to divide by negative 1. And dividing by negative 1, all it does is switches all the signs. So negative y becomes positive y, this becomes negative 1 over x minus 2, and this becomes positive 1. Again, I'm going to rewrite it as f inverse of x equals negative 1 over x minus 2 plus 1, because it started with f of x equals. I want to show you one more trick, which is that when we were at the step where we had x minus 2 equals 1 over negative y plus 1, there's a cool thing you can do, which is you're allowed to take the reciprocal of both sides. And this is a little bit faster sometimes. So the reciprocal of 1 over negative y plus 1 is just negative y plus 1. The reciprocal of x minus 2 is 1 over x minus 2, and that skipped us straight to this step right here. It got rid of some of the kind of confusing algebra steps if your algebra isn't great. One last problem I'm going to do is we're going to talk about how to graph this function and its inverse. It says to find the inverse of the function, graph both the function and its inverse. I'm going to start by finding the inverse. X equals negative 3y plus 15 over 4. We're going to solve for y by multiplying by 4. 4x equals negative 3y plus 15. And we can subtract 15 on both sides. And finally, divide by negative 3 to get y by itself. Negative 3 doesn't go in evenly here, so we're going to get negative 4/3 x. Negative divided by negative is a positive, equals y. So g inverse of x is equal to negative 4/3 x plus 5. Now, this is easy to graph. The y-intercept is 5. This is g inverse of x. The slope is negative 4/3, so we're going to go down by 4 and over by 3, down by 4, over by 3. We're going to make sure we put arrows on the ends of our line. This is the original function. This is the inverse function, but it also said to graph the original function. This is kind of a gross function to graph. If we simplify it, we get negative 3/4 x, which isn't that bad. 15 divided by 4 is 15/4. How do we put that y-intercept on our graph? Well, this is a good opportunity to change it to a mixed number or a decimal. So the decimal version would be 15 divided by 4 is 3.75. That's pretty easy to put on the graph right here. Or you could say 4 goes into 15 3 times, and there's a remainder of 3/4. So 3 and 3/4 would give you 15/4. Either way, here's our y-intercept. The slope is negative 3/4, and we could go down by 3, over by 4. We have to be careful to stay exactly down by 3, which means we'll end up at 0.75 and over by 4. So we won't be using whole numbers, or we could use the fact that a slope of negative 3/4 there's another interpretation besides down by 3 and over by 4. We can also just go down by 3/4 and over by 1. And going down by 3/4 and over by 1 gets us onto an exact point. And from there, we can go down by 3 and over by 4, and that might be a little bit easier to stay on whole numbers. Either way, here's our inverse function. And if we want to check to see, did we do it right, we can kind of graph the parent function, the linear parent function, y equals x, and we can see that it is a reflection across that line. I hope this helped. Good luck on the rest of your homework.